hypothesis testing. Yesterday we talked about, we had the Pinky example and where we looked at what the p-value was, and today we're going to look at some more examples of hypothesis testing. One of them is going to be comparing a mean to a value, and one's going to be comparing a proportion to a value. Sounds not very exciting, but it's okay actually. This is an important principle for you to know, and I've already talked about the 2 YouTube videos. I went and watched the p-value one again, and it really does help you to understand. It's quite popular, and I think it's well worth the effort of watching it. Okay. Alright, now I've just got over here, I've got the showing the different things in this. So look, we've got the 4 YouTube videos here, but as well we've got these handouts. It's a good idea to go and check every single one of these things down the side here, because they're not there just for the heck of it, they're there to help you learn. And I think, well, this one here, the chi-squared one, you'll just really, really need. But that's next week's stuff. Okay, are there any questions about how the course is running or anything like that? No? Cool. Okay, so 5 steps of hypothesis test, and we introduced that idea yesterday. And so we've got the 5, I've just reiterated the 5 here. So we decide on what it is that we're trying to do. And there's been a couple of people do Module 6 A quiz, and one of them is having trouble with rejecting or not rejecting and so on. So it seems as if this stuff is straightforward, but it's not. So you've got to think about what are our hypotheses. Our null hypothesis is what we think isn't going to, or it's the status quo, and it's the thing we're trying to disprove. And we did one-tailed or two-tailed, and then you collect our data, calculate the p-value, make your decision. Now this bit here, this you just about need to memorise. There will be questions that pretty much make you fill in the gaps for that, because it's really hard to interpret the p-value unless you have sort of like some sort of definition in your head. So the idea is that it's the probability of getting by chance a sample at least as extreme as the observed one if the null hypothesis is true. So it's saying if the null hypothesis is true, what's the chance that this could happen? So when we had the pinkies, the null hypothesis was that 1/3 of the things in the bag were pinkies. If that were true, how many pinkies are we likely to get in a row? Well, probably 3 or 4 is possible, but getting 7 in a row is very unlikely. And this has been a very popular little expression I found on a different YouTube video written by somebody else. P is low, null must go. Basically you need to engrave that on your brain. So anytime you see a low p-value, and low generally means smaller than 0.05, that means the null hypothesis will go. So if we have a low p-value, we reject the null hypothesis.